We are graphing simple rational functions, and in this case, we're talking about in the form of f of x equals a times x plus b divided by c times x plus d. When we want to calculate the vertical asymptote, that's when we're going to set whatever's in the denominator equal to 0, and that's going to give us our vertical asymptote. Our horizontal asymptote is going to be calculated by taking the lead coefficients and making a fraction where we say a divided by c, and that will give us our horizontal asymptote. So we can take a look at what we have here. And the first thing we want to calculate is our vertical asymptote. So in this case, we want to take whatever's in the denominator. So we have negative x minus 1 equals 0. So we can add 1, and then we get negative x equals 1. And then we want to get x by itself, so we can still divide by negative 1. And then we get x is equal to negative 1. So that's our vertical asymptote is x equals negative 1. Now we get our horizontal asymptote by taking our lead coefficients, which in this case we have y equals a divided by c. So in this case we have y equals negative 3 divided by negative 1. So y equals 3 is our horizontal asymptote. So we can graph these two lines here. A vertical asymptote is x equals negative 1. And our horizontal asymptote is y equals 3. Next thing we want to do is we want to pick a few points that we can use. And we want to be on either side of the asymptote, the vertical asymptote. So we can pick 0, 1, and 2. Those will be to the right. And then we can pick negative 2, negative 3, and negative 4, and those will be to the left. So if we substitute in 0, we get the first term drops out of each of those, so we get 2 divided by negative 1, which ends up being negative 2. If we substitute in 1, we get negative 3 times 1, which is negative 3, plus 2 is negative 1. And then we get negative 1 minus 1, which is negative 2. So in that case, we get 1/2. If we plug in 2, we get negative, or 2 times negative 3 is negative 6, plus 2 is, that's negative 6 plus 2 is negative 6 plus 2 is negative 4. And 2 is negative 2, minus 1 is negative 3. So then we get 4/3. If we go with negative 2, then we get positive 6, which is plus 8. So we get 8 in the numerator. I'll write this down here. 8 in the numerator. And then negative minus negative is 2. So 8 over, that's positive 8 over 1. So then we get 8. If we substitute in negative 3, we get 9 plus 2 is 11. And negative negative becomes positive 3 minus 1 becomes positive 2, 11/2, which is 5.5. And if we substitute a -4, we get 12, we get 14 in the numerator, and we get 3 in the denominator, so 14/13, which is 4 2/3. So we can go ahead and graph those points. And so we get 0, -2, so 0, -2. Then we get 1 1/2, so 1 1/2. 1 1/2 is up here, it's not -1/2. And 2 4/3, 4/3. And so we have a graph that comes through and it looks a little bit like that. Then we have -2, 8, and that's off our graph, and -3, 5.5, so we can get close to where that one should be, and -4, 4 2/3. So this one's a little bit less showing up on here, but we can get that corner graphed on what we have sketched there. Then we can talk about the domain and range. For the domain, it's defined everywhere except x equals -1. So we'll start at -infinity, and we'll go to -1, union, and we'll start at -1 and go to infinity. And then for the range, we're going to start at -infinity, and we're going to go to 3, union, and then we're going to start at 3 and go to infinity. And we can take a look at what that graph looks like. We have our vertical asymptote at +1. Oh, I have this equation graphed in here incorrectly, so let's change this to -1, and then this has to be -1. There we go. We have our vertical asymptote at x equals -1, and we have our horizontal asymptote at y equals +3, and then we have our hyperbola graph there.